On this Chevrolet Silverado diesel, P0335 means the engine control module may not be seeing the crankshaft position signal the way it expects. The truck may crank longer than normal, may stumble or stall, may not start, or may set a warning depending on when the signal drops out. Broadly, this can involve the crank sensor, its reference voltage feed, low reference, signal circuit, connectors, the engine control module side of the circuit, or possible mechanical sync issues around the reluctor and timing drive. The crank sensor is watching a reluctor with 58 teeth or invisible magnetic segments, arranged at a 60-segment spacing with 2 missing segments for the reference gap. One monitor gate for P0335 is the MAF sensor greater than 2.0 grams per second. For P0335, the diagnostic formula is loss of crank signal, no signal for greater than 4 seconds, greater than 0.3 seconds, or during 2 engine revolutions. Start with the basic system checks, then follow a structured diagnostic approach before getting into pinpoint testing. Put the ignition on with the vehicle in service mode. Before chasing the crank sensor circuit, make sure a reference voltage fault is not set. If that kind of code is present, diagnose that first, because it can pull this whole circuit in the wrong direction. Then run the engine and check whether a crank sync or performance code is present. If it is, move into pinpoint circuit testing. If it is not, watch the crankshaft position active counter. That counter should increment. With the engine running, watch the crankshaft position resync counter. It should stay at 0 counts, and the engine should not stumble or stall. While watching it, wiggle the harness and connectors at the B26 crankshaft position sensor and at the K20 engine control module. If the counter goes greater than 0 counts, repair the wiring, terminals, or electrical connectors as needed. If it stays at 0 counts, reproduce the operating conditions for the code or the captured conditions from when it failed, and verify P0335 does not reset. If it resets, continue into circuit testing. If it does not reset, that path is all okay. For circuit testing, turn the vehicle and all systems off before disconnecting anything. Be aware it may take up to 2 minutes for all vehicle systems to power down before an accurate ground or low reference continuity test can be made. Then disconnect the B26 crankshaft position sensor connector and begin at the low reference circuit. Test for less than 10 ohms between low reference circuit terminal 2 and ground. If it is 10 ohms or greater, disconnect the K20 engine control module and test the low reference circuit end-to-end. You want less than 2 ohms between low reference terminal 2 at the component harness and the other end at the control module harness. If that end-to-end test is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the supported outcome is replacing the K20 engine control module. If the low reference test is less than 10 ohms, turn the ignition on with the vehicle in service mode and check the 5-volt reference circuit. Test between 5-volt reference terminal 1 and ground. The expected range is 4.8 to 5.2 volts. If it is less than 4.8 volts, turn the vehicle off, disconnect the K20 engine control module, and test for infinite resistance between 5-volt reference terminal 1 at the component harness and ground. Less than infinite resistance means repair the short to ground. If it is infinite resistance, test the circuit end-to-end for less than 2 ohms. If that is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the supported outcome is replacing the K20 engine control module. If the 5V reference test is greater than 5.2V, turn the vehicle off, disconnect the K20 engine control module, then turn the ignition back on with the vehicle in service mode. Test for less than 1V between 5V reference terminal 1 at the component harness and ground. If it is 1V or greater, repair the short to voltage. If it is less than 1V, the supported outcome is replacing the K20 engine control module. If the 5-volt reference is between 4.8 and 5.2 volts, move to the signal circuit simulation. Rapidly tap a 3A fuse jumper wire between signal circuit terminal 3 and ground, and watch the crankshaft position active counter. The counter should increment. This is where the scan data tells you whether the control module can see a simulated crank signal through the signal circuit. If the active counter does not increment during the jumper test, turn the vehicle off. Disconnect the K20 engine control module, Then turn the ignition on with the vehicle in service mode. Test for less than 1 volt between signal circuit terminal 3 at the component harness and ground. If it is 1 volt or greater, repair the short to voltage. Then turn the vehicle off and test for infinite resistance between signal circuit terminal 3 at the component harness and ground. Less than infinite resistance means repair the short to ground. If that is good, test the signal circuit end to end for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the supported outcome is replacing the K20 engine control module. If the active counter does increment, check whether the crank sync or performance fault is set. If it is set, inspect for related mechanical, material, and installation problems. Sensor installation and looseness, connector and harness condition, reluctor damage or alignment concerns, foreign material between the sensor and reluctor, excessive play, oil contamination, sprocket wear, and timing drive or tensioner wear. If one of those conditions is found, repair or replace as necessary. If those conditions test normal, test or replace the B26 crankshaft position sensor. If the sync or performance fault is not set after the counter increments, test or replace the B26 crankshaft position sensor. After the repair, verify the repair and confirm the code stays gone. Keep verification separate from the circuit testing. Run the vehicle under the needed operating conditions, and make sure P0335 does not reset. If the service emission system or service exhaust fluid system message is displayed, perform the reductant system tamper warning service bay test. That function clears the applicable driver message. The takeaway is simple. Prove the reference feed, ground, low reference, and signal path before condemning the sensor or the module. For more diagnostic training, visit stepdiagnostics.com.